I was recently able to acquire those rather funky looking radio headphones from the 1960s. They are supposedly the very first truly wireless headphones. On each side they've got a telescopic antenna, which is a very unique aesthetic, especially nowadays. They were rather cheap, but that's because the seller told me that the left channel is not working. In this video I want to tear it apart, try to fix it, maybe replace some of the old electrolytic capacitors and also clean them up, because in the state they are in now they are absolutely rancid. Even touching them with my hands is disgusting. Definitely wouldn't want to wear them on my head right now. Before I do anything too drastic, I want to actually confirm the claims of the seller. Put some batteries in. Now, usually with things this old, you might want to actually check the electronics before powering them. If there are any shorted electrolytic capacitors or anything like that, it could produce more problems for you to fix afterwards. In this case, I'm just going to risk it. Good thing I didn't do anything too drastic already, because it's not the left channel that's not working, it's the right channel that's not working. There are also a lot of contact issues. And you really have to play around with this level switch here at the side. But a bit of contact cleaner should fix that right up. Luckily I've also got access to the service manual, which tells me that those ear pads can be pulled off quite easily. Here you can see these little metal latches. You should be able to remove those ear pads without damaging them too much. Next step would be to remove the baffle. Ooh, look at that. Paper cone speaker. Typical 1960s radio. It was quite common for radios back in the day to have a switch integrated into the output jacks, because those are output jacks for the radio, not input jacks. And usually if you put something in there, it would remove the speaker from the circuit to, just output into your hi-fi system or whatever you wanted to connect to it. And my hope is that in this case, this will be the only issue. Just a bent contact, which can be cleaned, bent back, and therefore get the speaker to work again. It couldn't have been this easy, right? The connection is fine, the speaker is also fine, and looking at the speaker wiring, it goes into the other cup. Here is the radio part, and in the other cup there is the low frequency amplification part. Here's the inside of the other cup. Output transformers, pretty nice. I can't really get at the PCB for any measurements while it is inside of there, so I first have to remove this part here. I'll have to undo some screws here. I also have to carefully unscrew the output jack here. I was able to remove this jack, but I think I've got a big problem. Someone was in there already, because those resistors back here, they are the old style. Those blue ones are most likely metal film ones, which are rather new. The older ones are those ones here. No resistor from the 1960s looks like this. I was able to trace signal for the left channel right until the input of the power amplification stage. Sadly, the power amplification stage is this little IC here, which is very hard to replace, and it seems like this is the one that's defective, because input of this IC, signal, output, no signal. At the output there should also be around half of the supply voltage. On the other channel there is like 2.4 volts, something like that. On the left channel 4.5 volt, full output voltage of the batteries. So I'm guessing that the IC is dead. Sadly, nothing I can do about it except maybe find a replacement, which is pretty hard. Maybe I can whip up something else. Just to make sure, I replaced 2 of the electrolytic capacitors and checked other critical components, and everything is fine. The output transformer is also fine. It really is this IC here. It doesn't seem like there is a way for me to get this IC. After desoldering the output stage, I noticed something quite interesting. The resistor of the channel that is working here has 800 kilo ohms, while in the schematic it should be 820 parallel with 820, so right around 400 kilo ohms. And this one has 400 kilo ohms. So this is the actual value that this resistor should have according to the schematic. However, this belonged to the channel that didn't work. So I guess I will try to replace this one with 800 kilo ohms, resolder this IC and see if it works. Since I wasn't able to find a suitable replacement, I built this. It's just a single operational amplifier. Already tested it and it does work on its own, so now I will build it into this circuit and see if it works. I decided to use a 10x amplification. In practice the amplification factor will go down even further because there is some feedback already in this circuit. I built this to be really a drop-in replacement, just solder it in and there you go. You don't have to change any of those values in the original circuit. So just in case me or anyone who might own this in the future found a replacement AN127 IC, they could just, get this out and get this IC in there and it should just work like that. The new amplifier has been installed. If the amplification is too much or not enough, I can just change this little resistor up here. This is the feedback resistor for the operational amplifier, so changing it will change the gain. And now it's time for a first test. I can hear something. It's really quiet, so I'll have to give this a lot more gain, a lot more amplification. And that's the other channel, nice and loud. This one. Almost nothing. Had to use a 10 mega ohm resistor. Sadly I don't have any SMD ones, but this channel, it is working now. It's still too quiet. I've now removed the feedback resistor completely, since technically the whole circuit here has some feedback, and this seems to be fine. I now put some heat shrink tubing around the replacement IC and also cleaned this switch out with some mild contact cleaner. Now it seems to work fine and I will assemble it and give it a final test. But before I do that, I just wanted to quickly show you the schematic of the circuit I just built. It is essentially an inverting operational amplifier, but the feedback resistor as well as the input series resistor are now externally, so there is no need for them to be here. There is also a voltage divider, which gives the operational amplifier a reference voltage, which is around half of the supply voltage. So the output will also be half the supply voltage while in idle. When it comes to the selection of the operational amplifier, it's not all too critical. It just needs to work with the low supply voltage of 4.5 volt in this case. And it also could ideally or should ideally be a low noise type. I did not use a low noise type and I live to regret it because it does produce quite a bit of noise in comparison to the other channel. So keep that in mind if you want to build something like that for yourself. Everything's screwed back together and they still work. I have also cleaned the ear pads. They are now acceptable. I will have to reinstall them, which will be quite tricky. Getting the last hook in was quite a challenge, but besides that, it actually was quite easy. By the way, the original foam inside of these ear pads is still in very good condition. No disintegration whatsoever. I don't really know how that's possible, but I'll take it. Both channels are working. Very nice. Overall, I really am quite happy with the result. Obviously, the sound quality leaves much to be desired. It is late 1960s technology after all. The radio reception is pretty good, surprisingly. I can really receive quite a lot of stations, which I cannot receive on many other radios I have. But besides that, they make a great addition to my collection. They are some of the most unique headphones I have ever seen. So again, I am really quite happy with them. If you enjoyed this video, like and subscribe, and until next time.
Vloga v reprezentanci tudi tak igralec. Stop, zdaj ajde. I sotno.
Zloča neposredno v